Tali Lopez is going to be speaking on the challenges and solutions for small water systems related to 123 TCP. Tali is the manager of water quality for Cal Water, and she has over 20 years experience managing water quality, wastewater, and environmental compliance across the U.S. She has a BS in environmental biology and water treatment and distribution certifications issued by the state of California. So thanks, Tali.
Good morning. This morning we're going to be talking about challenges and solutions for implementation of treatment for 1,2,3 trichloropropane. So just a little glimpse of the agenda, some of the items that we're going to cover today. We're going to go through the background on the MCL, the granulated activated carbon treatment technology. We'll do a case study of one of Cal Water's systems. We'll go through the design and acceptance of facilities and also look at some permit conditions and lessons learned. And I'm not going to present very much on the operations of these treatments once they're installed, but I'm going to focus more on the design and construction phase. So the road to the MCL has been long and winding. Starting back in 1999, there was a notification level established here in California, and then UCMR testing began in 2001. Fast forward to 2009, the state of California, through OHIA, the Office of Environmental Health Hazard and Assessments, issued a public health goal of 0.7 ppt, which is really how we got to the final result of where our MCL is at. So we now have an established MCL at 5 ppt, which is very low. It's right at the detection limit of our analytical capabilities. And so this is, like I said, it's been kind of a long road, but we now are at the place where we need to comply with this MCL. So just a little background on 1,2,3 TCP. It's a man-made chlorinated hydrocarbon. It was used as an industrial solvent, cleaning and degreasing agent, and paint remover, and then also as a minor component or ingredient in a soil fumigant where they use TCP in the fumigant. Because of that interaction is how it got into the majority of our groundwater supplies in the Central Valley. And of course, it's very persistent in groundwater, and it travels very quickly through the soil phase right down into the aquifer. We saw this map before when Eugene presented this morning, and his version was a much better copy of it, so I apologize for the quality. But you can see the red dots. We have most of the contamination in the Central Valley and agricultural areas. In some of the coastal areas and down in Southern California, there may be some industrial contamination. So let's talk a little bit about GAC as a best available technology. So BAT means best available technology. It's a regulatory term. When they issued this MCL, they specified that GAC was the technology for treatment for trichloropropane. So just a little background on how GAC works. The design consists of several vessels that are different columns of the granules of the GAC material. It's designed to absorb hazardous chemicals, and as the water flows down through the column, the chemicals absorb to the porous surfaces of the granules. So each individual granule that is very, very small has, possibly hundreds, if not more, little surface area on there that the contaminant can adhere to. And the type of design is it's a downward flow of water through the column. So the water comes in through the top of the vessel, and then it flows downward through the column. So a little bit more about GAC and just in terms of thinking about the surface area and what it can do. So 5 grams of carbon has an internal surface area equivalent to the surface of a professional football field. that is a measurement that is just so vast. I mean, it's amazing what these little tiny particles can do. The GAC that's available is 99% graphite with carbon as its element, and graphite is used in a lot of different things. Even like tennis rackets, lubricants, all different kinds of things. So I'd like to talk a little bit about one installation that Cal Water did in their service area. And just to back up a little bit, so last year with the implementation of this MCL, Cal Water statewide designed and installed and implemented 38 new GAC treatment systems in our service areas in California. And then in an area where we operate for the city, in the city of Bakersfield, we're now operating approximately another 40. So in a short period of time, we embarked upon a treatment installation of a scale that we had never anticipated or gone through before. And due to some of the things that I'm going to present to you throughout the rest of this presentation, I think we were really successful in that effort. We have had no violations of the MCL or malfunction of the treatment, and it's something that we're really proud of. I'd like to just talk a little bit about our Tolko system. So Tolko is a small water system near the city of Tulare that serves just 200 customers. So we had several wells there, and some of them we had originally had GAC installed on a well, but then that well collapsed due to sanding issues, and then eventually the well did not become useful, and so then we had another well on the site, and we actually have 3 total wells on that site. To date, only one of them is usable, and that's the one that we installed our TCP treatment on. So one of the challenges we faced in that treatment is we started, prior to installing the treatment, we were planning just for TCP treatment. We had some elevations of nitrate in that well. And so we felt it was kind of on the margin, kind of on the borderline, so we felt we needed to do some testing and install nitrate treatment in combination with the TCP treatment. And that's something that we hadn't done before, and it's not really recommended in the design phase because it adds a level of complexity to the treatment train, and you can sometimes have issues with bacteriological problems and that type of thing. And I'll talk a little bit later about nitrate sloughing, but that was the reason why we installed the nitrate treatment there, was for nitrate sloughing. And so we started off with a temporary unit that was leased, and we now have purchased that unit to make sure that we're controlling any nitrate spikes. So the other challenge we had at this site is that it was very difficult to discharge water to waste. So when we're starting up the treatment, there's a number of different flushings that have to occur with the disinfection of the vessels that are installed, and then just with getting the GAC loaded in and that type of thing. So there were some challenges with that. So just some things to think about. And then, we eventually got the GAC installed for the TCP treatment and a small, at that time it was a temporary nitrate treatment system using ion exchange. One other thing that was really important to us in this installation was the use of an emergency interconnection with the city of Tulare. So as this was our only source out there during the time when we had to shut down for the connection and for the construction process, we relied upon the city of Tulare. That has allowed us, because of the challenges we had with that, to justify putting another well out there. So we're eventually going to add a secondary backup well out there. And then we ran to system with compliant water in May of 2018. So I'll talk next about some of the preliminary design considerations and some things that we looked at. Data analysis was a very important part of this process when we were determining how many vessels we needed, what the empty bed contact time was going to be. We had to really know what the concentration was in the well, as well as other co-occurring contaminants. We also looked at site improvements. So if we were going to do construction at a site, we looked at things like repairs that may have to be done on the electrical panels or the well itself, any other housing or fencing site improvements that were going to be a part of the project. We also completed a safety and ergonomic review, and I think this resulted in a great design for our operations staff. We actually looked at the height of the valves and the orientation that they were in order to be easily accessed, and we decided to install safety ladders on all of our units, which was the first for us. We had not done that in past GAC installations. We also looked at the site layout, and so that has to do with making sure that if you put these new vessels in, that you still have room on your site to get if you ever have any repairs that are needed with the well. And in some cases, we had to we either leased adjacent property or purchased adjacent property if there was not enough room on the site. And of course, we ended up with a 2-vessel lead lag configuration as a minimum design requirement. So with our MCL so low, we had to make sure that we had the secondary vessel kind of as our backup. And they're designed where you can isolate each vessel, and you can do a 1-vessel change out at a time, or you can do 2-vessel change out. So it gave us some flexibility on that. We also had to look at pressure loss through the treatment system. So we really had to make sure that we understood what the constraints were with the well pumping and all of that. And then we installed a bypass valve arrangement so that as we were coming up to the implementation of when we had to take our first samples, we were bypassing treatment until the treatment was constructed, and then it was connected into our system. And then there were also, of course, operational considerations, discharge requirements, and then planning for summer demand. So our schedule was designed to get the majority of our critical facilities up before late spring, so that we had our sources ready to go for summer demand. So just a quick view of the system overview. I'm going to just show you a couple of different pictures of some of our basic design features. That have to do with pressure transducers and flow meters, chlorination, a sample station. At the effluent, you have to establish your sample point for compliance, and then any blow-offs. We did have several other wells that had nitrate, and so we designed an automatic blow-off and well shut down if nitrate reaches certain levels. And so they had to design the discharge for that automatic blow-off. So let's talk a little bit about nitrate sloughing. So Division of Drinking Water requires weekly monitoring of nitrate if you're treating a source that is greater than 1/2 of the MCL. So nitrate basically is kind of some type of equilibrium process that happens on the GAC material, and it can last from hours to minutes after starting or restarting the equipment. So the nitrate will kind of hold onto the GAC, and then it will come off in kind of a flush at the beginning of startup or after you've been down for a little bit. It can sometimes peak at 2 times the raw source level, so it is a concern to us. We want to make sure we don't have high nitrate in our distribution system. And then you can sometimes have higher levels of sloughing after longer rest periods. So these were the things that we tried to design into the treatment. So the next couple of slides, I'm going to talk about the acceptance of facilities. So this is after we're through the construction process. We went through a series of steps to make sure that our system was designed as appropriate, didn't have bacteriological problems, and there were other things that we could assess throughout that process. So, of course, we did pressure testing at the beginning for the vessels themselves, and then we took bacteriological samples to ensure that we had compliance with our water quality compliance, and as well as the permit conditions. And then we also were monitoring to make sure that we didn't have any pressure drops. So we wanted to make sure our pressure drops were less than 10 psi across the system. So one of the things that we did to document this process is we had these startup checklists. So this one, I know it's a little hard to see, but this one is for our water quality sampling data. So I'll go over to the next spreadsheet. This was our final spreadsheet, or our final checklist that each department had to sign off on, and then attached to it was the corresponding water quality data and any of the testing that we had done, so it was all in one packet. So before we ran water to system, we ensured that all departments, our operations, our engineering, and our water quality departments all had reviewed the material and agreed that this system had been designed as appropriate and was ready to run to system. And I think this is a really important process to go to. It's something that is easy to kind of forget at the end when you have this treatment system constructed. You really want to follow it through all the way to the end to make sure that you have everything designed as appropriate. So I'm just going to show you a couple of pictures of what the vessels look like. And just some of the things we did. We use magnetic labels for the vessel labeling. So it'll say either lead or lag. And in the event that the configuration gets switched, because if we do a change out on one vessel, then once that vessel has the new GAC material in it, then we're going to switch the configuration, and then the lead becomes the lag. And so that was important for us to keep track of. And then, of course, piping labels, especially for our operations staff to really understand, the direction of flow and how the valving work. We also had process flow diagrams that we put up into our well stations because it was really easy to kind of get things going the wrong way. And with a little bit of trial and error, we determined that was the best way to inform and, provide training for operations staff. Here are just a few pictures on how we fluidize the vessels. So you can see the unit there on the left is the Calgon. Our vendor Calgon has designed a special bed for us that has a sacrificial carbon compartment in it, so when we're washing the fines, we don't have any problems with our discharge permits. So it's something we do on all of our GAC, our changeouts, as well as first fill on our GAC. And in some cases, there are some real discharge challenges. At some of the sites, they may have to bring in Baker tanks, or there's discharge out to street that has to be monitored and has to comply with our NPDES permitting. So just a little look at the process from start to finish. Just a pictorial of kind of some of the different steps. There was a lot of kind of safety concerns along the way, and so we really made sure that everyone had a focus on that, and we were able to get these installations safely installed. So I'd like to summarize a little bit about the permit conditions for our drinking water permit. So we started out we got our first approval in late December. So we got the MCL December 17th, and we had our design and our crew ready to go for construction. Just a couple weeks later, we got our first what are called conditional use approvals. And of course, as a part of that, you have your operations plan. And this is a very important piece of the permit. You really have to make sure that whatever you have in your operations plan, your staff is trained on and is following it, because it is actually a permit condition that you follow your operations plan. And we also were, the permit specifies the monitoring. So, of course, we're monitoring for residual chlorine, total coliform, and E. coli, heterotropic plate count, and we need to make sure that those levels are under 500. And then, of course, the contaminant that you're treating, or if there's other co-occurring contaminants, and if there's an issue with nitrate, you need to be monitoring for all of that. And then we specify daily site visits. That's something that we do as a part of our operations plan. Anytime we have any type of treatment at a site or chlorination, we're doing a daily visit. And then one of the important parts of this process is doing the monthly reporting into Division of Drinking Water that's required every month. So there was a lot of report design and making sure the right data was showing up on the reports. And we started out with a commissioning period, so you have 4 weeks of weekly sampling, and then if everything looks like it's working properly, and this is, of course, while it's running the system, then you can go to monthly sampling. So to really get all that data during that 4-week period of time onto our monthly reports was a challenge, and we made sure we coordinated to make sure that data was on there. One unique requirement of the permit amendment was an annual report. And so we just submitted the first of those for our systems a couple weeks ago. And the annual report is just meant to describe, any issues that we had with the treatment, if we had to do any GAC changeouts, if we had premature breakthrough on the carbon, to describe any issues. And so that was kind of interesting, and I think it was well received by the district DDW office. We did receive some good feedback on that. And so that is now a permit condition for us. We will be required to submit those annual reports every year. And then one permit requirement is that we are to use virgin GAC. So there is plans this year within Cal Water to do some testing and to look at using a reactivated GAC material, which is where they take the GAC out from the vessel and the vendor takes it back and they kind of refire it, and it puts all new kind of surfaces onto the GAC particles. So we are going to be looking at that this year. It is a significant cost savings, and within Division of Drinking Water, we will be starting, some preliminary discussions on that process. Reactivated material is used statewide in drinking water systems, but for TCP, they specifically asked us to kind of hold on that and not put it into our ops plan and not do it until we had done some testing and developed a plan for that. Okay, lessons learned. We'll go through a few things on some lessons we learned throughout this process. So, of course, at the top, making safety and ergonomics a priority. And this was really a great process for us to work for. We really sat down, the engineering team and the operations team, and in particular, what they were really concerned about was how they were to access valves and where the valves were located. And so I think we made some really good improvements on the design to make these systems easy for our operations staff. Because in one district, they have close to 30 of these treatment systems and then another 40 that they're operating for City of Bakersfield. So they really need to make sure that this is work that is going to be ongoing. They're going to be doing, for the life of these treatment systems. So I think that was a really good thing that we did. We also started with a chartering agreement, which is a process where you bring all your internal teams together and you develop some agreements and a way that you're going to work together and establish goals and deadlines, and then have a commitment from the group to make sure that we're meeting all of those requirements. So I think that was also part of our success in being able to get these treatment systems online. And then, of course, start early on the permitting. The environmental permitting always takes a little bit, and the local city permitting always takes a little bit longer than any approvals we're getting from Division of Drinking Water, so we started on those early. Being able to engage with regulators early and often. This is something that, we did starting in late 2016. We knew this was coming, and we started our design and our discussion with our local engineers in 2017. And then communication with customers. This was really important for us because there was a little bit of media attention that happened when the MCL first came out, and so we had to, really communicate with our customers about what our plan was. Okay, a little bit more on lessons learned. Of course, utilizing a project management tool and software. This was something that helped us through our process. We also, from an engineering standpoint, they tried not to kind of over-design things. There were some things, like especially with, initially they were looking at some valves that were kind of more automated, and they decided to kind of back away from some of that automation due to the maintenance of that type of requirement. And then also to ensure that we were backwashing or fluidizing properly. And to make sure that we were really working with our vendor on that, and that the operations staff understood how to do that. And then, of course, designing in the ability to discharge water. So this can definitely be an issue, especially in our small system at Tulco. We did not have a way to discharge water, and we had to get permission from a local landowner in some cases. In some cases, it was hauled off. It is really a challenge. And then also to consider system station pressure losses. So there were a couple of systems that we started up where we had some unusual pressure losses at the beginning, so we had to troubleshoot those and work through those. And pressure is actually one of the things that you'll have to monitor for going forward, because that's going to show you if you have some problems with the treatment system. So that concludes my presentation. Does anyone have any questions? Thank you.
There we go. I'm going to go ahead and try and get your questions in the microphone so that we can have them recorded, so future viewers will be able to hear what everybody's saying. So,
Where your permit requires you to sample for HPCs, and did you have a high levels of HPCs so far, and how did you address them?
Yes, that's a great question. So we did have some high levels of HPC in some of our systems, and they ended up just doing, just flushing the system out. And really what helps, what we've observed, what helps with HPCs is just, running it. So in some of them, we had to run to waste for a little while to clear them out, but it was very, I think it had to do with the summer heat too. Some of the ones that we were installing later in summer, those were the ones that we noticed we had more issues with. Just at the effluent. Yeah, at the effluent. Before chlorination is where we're sampling.
One point or midpoint also?
Yeah, so we do have multiple points to sample along the way, but for HPC, so I'll back up. When they first constructed the vessels, we did do sampling at each location along the way. So each vessel you can sample out of it, and then there's an intermediate point, and then there's another point, and then there's an effluent. So we did sample at multiple locations before we loaded the GAC. But then at the end, when you're looking at compliance, where you have to be in compliance for your permit, we're just sampling for HPC at one location, and that's the effluent.
Like blended effluent?
Yes.
From all the
correct.
vessels?
Yes, that's correct.
Thank you.
Apologies if I missed it at the beginning, but what was the throughput capacity and the empty bed contact time of this system?
Yeah, I don't have the information on the empty bed contact time, but the capacity, like some of our wells were well over 1,000 gallons per minute, and some of the sites, depending on the concentration of TCP in the well, we were up to 6 vessel pairs. So we may have, not 6 vessel pairs, 3 vessel pairs. So you would have 6 total vessels. That's a great question.
Square footage of the well sites with everything implemented, and then maybe a cost of maintenance, like an annual cost?
Yeah, so I don't have that information handy, but feel free to contact me, and I can figure that out for you. Yeah.
I have a question, if nobody else does. What's your criteria for GAC replacement?
For what? Oh, yeah, so we are doing a little bit, I think it's a little bit of an unusual change-out process. So we're choosing not to do the one vessel change out at a time because it's a real issue for our operations staff. It doubles the number of times that they have to go through this change out site. So what we're doing is we're allowing breakthrough into that second vessel, and then at either 50 or 75%. So we have 3 sampling points on the side of the GAC unit, and at the 75% level in the height of the GAC unit, when we have TCP detected at that level, we're shutting the system down and initiating change out at that point. So it's on detection in the second vessel where we're initiating change out. And then of course, if we ever had anything, at the MCL. Another little side note, one thing we felt was really important to do with this is even though the MCL is at 5 PPT, when we can ask for our analytical data from the lab. We can see numbers less than 5 PPT that are statistically, relevant. We know there's something there. So that's one thing that we've really started focusing on too. Like we know at each one of these points where we're sampling, we understand, okay, we're getting close to 5 PPT. So we don't wait until we get that, where we're over the MCL or at the MCL. We're able to plan a little bit ahead because we're looking at that data.
All right, I think that wraps it up. Thank you very much, Tally.
Okay, thank you.